Alright, okay, so here we go, reviewing last night's homework, looking at 12 through 15. So, number 12, we had f of x equals 1 over x plus, and I got 5 over x minus 3. And the key concepts that we're looking for, I want to find the domain, range, and asymptotes. Domain, range, and asymptotes. And right off the bat, Mariah, help me find some of the asymptotes. And how did you know they were asymptotes? Okay, so Mariah tactic, she came to the calculator, so let's everybody go ahead, plug in your calculator with us. So I got 1 over x plus, now I'm going to put this in parentheses, I got 5 divided by x minus 3. Alright, and then you hit graph. Okay. And then Mariah, I'll let you take it over there. How do you know there were asymptotes and where are they? Yep. Take this part right here. Okay. So yeah. And let me just think, let's draw this graph real quick. I'll draw it right here. Okay, so we see that this graph is coming from negative infinity, dropping down this way. Then we've got a section that goes like this, and then I've got another section that's coming and going right here. So hot darn, right? A lot of stuff going on. Okay. Now the line that's on there, remember that's something that's very deceiving. That line is actually going to be one of those asymptotes we talked about. So that point that it goes right down there, when you see those big skips on your calculator, what that means is that's an asymptote. And how do I know that? Okay, so Mariah was saying like how she saw like it never crossed that x-axis. That's definitely going to be an asymptote. And the x-axis she was talking about here, you know, but it's an asymptote in that section, in this section. But what do you notice in this middle part? It actually does cross. But if I come here to my table, okay, let's look and see where we can find those errors. And you see at 0 and at 3, it doesn't exist. It says error. Yes, Megan?
Mine doesn't do that.
Okay. Well, here, hold on. Let's check the graph here.
Oh, I graphed it wrong.
Okay.
No, yeah, keep it right there.
Now, the reason why I put these extra parentheses in here is because if you actually didn't use the parentheses in the denominator, what happens is it just says 5 divided by x and then minus 3. So we got to make sure that x minus 3 is in a parenthesis in the denominator by itself. Alright, but Mariah, thank you for helping us get this problem started. Nettie, what can you tell us? Where are asymptotes then? If I'm looking here at my table, where are the two asymptotes? Okay, you don't know? Look specifically where we got the errors. So Thorn, I've got those two errors. What does that mean? What are those things? Those are the asymptotes. So I can come, and now I can, with confidence, be able to say that there's an asymptote at this line, which is x equals 0, and this line, x equals 3. So those are my two asymptotes I can write in. So x equals 0, x equals 3.
Oh, so where you see error is okay.
Okay. Now, sometimes you're looking for numbers and trends. Okay.
And sometimes like when you said change the ass and you put in like 1,000, I was like.
Okay, and that's why, because say if I took away this middle section right here, Monterio. Okay, so if I take away that middle section, do you see how both those orange curves, like they never really cross the horizontal axis or the x-axis. So that's why I wanted to check and see if they ever did cross. Because in that case, if I didn't have this middle part that crosses by the x-axis, that could impact my range where it never can go past that line. So I got to make sure to show that. So that's why I went really big to the right and really big to the left.
So you could cross from the expansion.
Because it could have crossed. Yeah, exactly.
Oh, I see. And the window too.
Yep. And that's why we did the hidden behavior in the first unit, because then what can you do with your window?
Expand.
You could expand it if you wanted to. Alright, so now, defining my domain and range. So Summer, go for it. What's my domain in this case? Okay. Domain deals with the x's. Okay, I did not. Where'd you get -1? Okay. Pelman, you want to help her out? So 0, yep. Okay, now do we include 0 or not include 0? Okay, so I'm going to go ahead, I'm going to put a parenthesis, and then what's next, Pelman?
You want to do the one in the middle?
Yep. Yeah, and you guys can even, yep, so 0, well, and actually here I want to go 0 to, what's this section? It stops at, yep, so I got to do this break in the action. So just this spot, and I know it's going to stop at x equals 3 because that's signified as an asymptote. So I'm going to go 0 to 3, not include 3 again, and then union, and then now this part, finish it out, Pelman. 3 to positive infinity. Nice job. Okay, so that's my domain. Now my range, we talked about how it's crossing, it's going up and down in every single direction. So there are no restrictions on my range. So if that's the case, when I talk about my range, Cody, what's going to be my range in this problem? Okay? And when I say there's no restrictions, yep, so it'll be negative infinity to positive infinity. So range always deals with your y's. So here, if I think of my domain, it's x's, range is y's, and I'm thinking of the graph as it goes up and down. Okay? So do you see any restrictions? Like if I look all the way around, there's no holes. Like there can be y values all the way up and down that whole thing. And this is where it gets real fancy. If I told you what would be your range on this section, and I covered up everything else, you see how it never goes above there? Yeah, so Cody, what would that be? So yeah, just this section would be 0 to negative infinity. Now if I looked at this middle section, that's where it kind of helps things out. And that middle section is, well, it can go up and down forever. So that's negative infinity to positive infinity. And then this last section, Megan, help me out. What's the range there? 0 to positive infinity, because it keeps going up. And yeah, I mean, if you specifically stated in your answer that from negative infinity to 0, your range was 0 to negative infinity, and then you said from 0 to 3, your range was negative infinity to positive infinity, and then if you said from 3 to positive infinity, that your range was, 0 to positive infinity, that is like, I mean, you talk about like A+ type work. I mean, you don't have to go that detailed in this basic sense, because I'm just asking for the whole equation. So I just want to know the restrictions on the whole entire thing. But if you did that, heck yeah, rock star status. All right, now let's look at 13. Yep. Yeah. Okay. So the domain, where that came from, and I'll use kind of this green section. So do you see how this graph was in this section? So that means that since it's going infinitely over this direction, and then it reaches all the way to this barrier, that it can exist from all of the x values from negative infinity all the way to this point where it reaches that barrier. And then when it reaches that barrier, there's one stopping point. So that's how the first part of my domain, I got negative infinity to 0. And then what we had to do is, it hit that barrier, But then you notice the graph joined up again and had a section right here in this little middle part. So with that middle part, I was able to say that the domain was 0 to 3. But then again, it hit a roadblock, hit one of those fences. So then it had to stop, but it joined up again, and it said that it wanted to exist again from 3 all the way to positive infinity. So that's how we got the 3 parts with the 2 unions. And the unions always join where there were breaks in the action. They join where there were breaks in the action. It's a good question, bro. Alright. Whew. Well, I believe it. This is where we got to practice. Because this stuff ain't going away. Alright, so see what we got here. My gosh, we've been rocking and rolling in this notebook. I got logarithmic functions. I got definitions. Oh, dear Lord. We're almost done with this thing. I think we are done. Okay. New number. Alright, problem number 13. Nate, I'm going to let you start it out. Okay? I want you to do everything with this problem. No, I'll let you start it. I'll let you start it just by telling me some things about the graph, Nate. So if I look at 13, okay, I've got g of x equals x over x squared minus 5x. Okay, and let's go ahead. I'll even draw the graph right away to the right. So we have a picture, and I can start doing some coloring. So I'm a big kid. I like to color. So you look at the problem, Nate. What's the first thing you think about? First thing you see. Yeah. So you want to go ahead and graph it? Okay, let's go ahead and let's graph it. Okay, so here I'm going to go x divided by, and then I've got x squared minus 5x. Okay, then I can go ahead and hit graph. It is a pretty weird thing, isn't it? Okay. Now, we see that you kind of got a trend that starts here, it goes down, and then we got this part right here that goes down. Now, let's check the table. Error at 0 and an error at 5. But it exists at all these other points to the left there. Alright, so now, me being fast forward, Nate, let me draw this graph using some color codes and stuff. Okay, and we haven't talked about something known as a hole. Like there are asymptotes and there are holes, but I want you just to think in terms of asymptotes. We can define that later. Alright, so we know that at positive 5, okay, there's going to be a barrier line because there's an error there. And I know at 0, there's a little barrier right there. So this part of the graph hangs really, really tight. It kind of comes, it stops at that line. And then we know that the graph continues from this line and then drops down. And then this part is saying that it comes and drops down here. Alright, now this thing here at 0 is one of those things that we're technically going to call a hole. Where it's going to have, this is supposed to be like an open circle. You can't really see it too well, but think of it as an open circle. Like it's like a hole that's there. It doesn't exist. And where that comes from, if I look at my denominator, you guys know that on the denominator it can never equal what value? 0. So what we have to do is we have to solve that part and set it equal to 0. So if I think x squared minus 5x, that can be factored. What do each of those things share? Shares an x.